Okay, so this is the last lesson on perimeter area and volume, and it's a lesson on scale factor. Scale factor is used when we have two shapes that are the same shape essentially, but are a different size. So the best way to think about this stuff is to think of maybe enlarging and reducing on a photocopier. So if we take a shape and put it into our photocopier and choose to reduce it, we're going to get the same basic shape. It's just going to be the magnitude of the shape has changed. So in similar shape, all the matching angles are equal and the matching sides are in the same ratio. It doesn't have, in order to prove you've got similar shapes, which you guys don't really have to do, you don't need to have both of those. If all the angles are equal, then they are similar shapes. And the major thing that people do struggle with here is this idea of the object and the image. If the question context suggests which one is the object and which one is the image, then do what the question asks. But generally, it's up to you to decide which one is the object and which one is the image. And as long as you label your shapes and work it out via the appropriate method, it won't matter which one you call which in most cases, as I said, unless the question asks you to do one thing or the other. So the scale factor is just the ratio by which, or the multiplier, I guess you might call it, by which the shape changes between its image and its object. So generally, we like to think about this form of the equation here. I'll just make sure I've got a good pen. There we go there. That tends to be what you want to think of most of the time. The scale factor is the image length over the object length. Everything else that's there is just basically using algebra to rearrange that initial statement. So as you can see, scale factor times the object length, that's just basically, we've just basically removed the denominator from the right hand side and moved it to that side. So if you just remember that one key formula, you'll be able to work your way around from then. So if the scale factor is greater than 1, then the object has been enlarged to produce the image. So we started with a small object and it got bigger. If it's less than 1, then the object has reduced. If it's a scale factor of 1, it means that the two are the same size. So having a look at this, we want to find the scale factor for the transformations below. So using that basic form of the equation there, so our scale factor equals our image over our object, which in this case is going to be 50 over 100. So the original shape goes as the denominator. 50 over 100, well, 50 is half of 100, so or better than that, 50 goes into both of those. 50 goes into 50 once and into 100 twice. So we've got a scale factor of a half. In other words, we've reduced the original object by half to make the image, which makes sense there. And with this second one, once again, we just use that same basic idea of the scale factor equals the image over the object, bearing in mind that a lot of the time it doesn't matter which one you call the image and which one you call the object. More than likely you're going to be asked to find lengths of the triangle rather than what the scale factor is. You'll need to work out the scale factor to find out the length of some triangle. So in this particular case, the image length is 75, the object length is 25, and you can see that 25 goes both into 75 and 25. So 25 goes into 75 3 times and into 25 itself once. So that leaves us with a scale factor of 3. In other words, the image is 3 times the size, or the dimensions on the image are 3 times the size as the object. Bear in mind, when we're talking about scale factor, we're talking about the changes to the distance, not the area. It doesn't work exactly like that with area, because obviously we have to then work out our area, and that will change slightly differently to the scale factor. So we then have example 2 here, in which two triangles are similar and why. So for them to be similar, we need to have the same angles in the same places. Now with triangles, although you've got 3 angles in a triangle, if you know that 2 of them are equal in 2 different triangles, well, therefore the third one must be equal, because that's all that's left. So we look here, and on this first triangle, we've got this little fellow here. Sorry, I was going to use a highlighter. I'll change again. There we go. We got that little fellow there and that little fellow there. denoting the size of the angles. And obviously on this next triangle, we've got a circle, but we've got a cross, so it's a different size. There's nothing to say for sure that those two are the same. But if we look on this last triangle here, there's that dot, there's that other angle symbol. So those two, although it's been rotated, it is the same triangle. So which two triangles are similar? Well, it's going to be, you know, if I go for, poor writing by me. If I go for A, I'm going to say the first and the third. Nice and simple. Once that's been said, it says state the scale factor. So bear in mind, sometimes you'll have to rotate these shapes in your head before you decide what the scale factor is. But the easiest way to look at this is, in between those two marked angles is a side of 7 on the first one, and on the second one there's a size of 3.5. So if I call this guy my object, and if I call this guy my image, then I just use that basic formula we had before. Scale factor equals the image over the object. And in this case, the image, that distance is 3.5, and on the same side of the other one, it's 7. Now, you could use the other sides, but I just grabbed that one because I thought it was the easiest one because it's between the two angles. Now, you can use your calculator here, but some of you might be savvy enough to realise that 3.5 is half of 7. So essentially, 3.5 goes into both those numbers evenly. 3.5 goes into 3.5 once, and it goes into 7 twice. So we've got a scale factor of a half. Now, if you'd done that question and you'd made the third triangle the object, you would have got a scale factor of 2 instead, but that would have been fine because it didn't say which way. So if you made the third one your object and the first one your image, you'd still be right. It'd just work a different way. Okay, so the next question is, are these two figures similar? Give reasons. And I guess I'm looking here at these markings on each of the sides and whether they all mark up the same. So if in my top triangle here at angle L, there's that angle symbol, and that's the same here. And if I go around clockwise, it's the same symbol, and if I go around anti-clockwise, it's the same symbol. So those ones all match up. And then, of course, opposite, they all match up. So all the angles match up. That's enough to say they are similar. Yes, because all angles are the same. But we can say also the sides are all in the same ratio. What do I mean by that? I mean that if we look at that first one, between L and B on the first quadrilateral, the distance is 7. Between L and B on the second one, it's 3.5. So clearly that's gone down by a half. But if then I look at between L and U on the first and L and U on the second, it's gone from 6 to 3. So it's halved as well. And as you work your way around the quadrilateral, you'll see that all of the dimensions have halved. But just saying that all the angles are the same is enough to say they're similar. So example 4, Bob measured the sides of the following shapes. Measured the sides of the following shapes and calculated the scale factor as 6/8 and therefore 3/4. And where did he go wrong? So, well, let's just think about it. If we worked out the scale factor, that's going to be our image over our object. So our image is, there's a problem, isn't it? Because this distance here on our image is between A and B. So we need to compare that here, but there is no distance for there. So he compared two different sides. So we can just come along and say, well, he compared two sides that are not matching pairs. Something like that. Okay. What should have told him he made the mistake? Now, this is a sort of a key understanding, and it might not jump out of the page for you, but it says that the scale factor is 3/4. So if it's a fraction, then we expect the image to be smaller than the object, but clearly here, that image looks bigger than the object. So the fact that he had that his scale factor said it was reducing, but actually the size increased. Okay, that should have pretty much told him what was going on. If the scale factor was 1.25, what would the side length BD be? So if we use that basic formula, scale factor equals the image over the object. In this case, we're going to have to work back a bit. So we've been told the scale factor is 1.25. And BD, we don't have a length on the image, but we do have a length of 8 centimeters on the object. So once again, we use our great algebra skills and we multiply both sides by 8 to get the image on its own. And if we take 8 by 1.25, I'm going to lean over here and look at my calculator. We get an image length of 10 centimeters. Okay. The final exercise we've got here is to find the scale factor of these two similar figures. So we've been told they're similar, so we don't have to find that. Now I'm going to say this is my object and that's my image. All right, just leave yourself a little I and O there so you can work it out. So the scale factor equals the image over the object. So we find two matching sides that have measurements. Obviously, there's some X's and some Y's there, but they're not really going to help me. So the side that I want to use is this one here because it has numbers for both and it's matching sides. So I'll use those ones. So the image size is 2, the object size is 8. So 2 over 8 is the same as 1 over 4, so there's my scale factor. So that's part A. And for part B, we need to find the two sides. So if the scale factor is 1 over 4, which is a quarter, or 0.25, equals the image over the object. So we'll do x first. The image length is x. The object length there is 12. So obviously I use a bit of algebra here. I multiply this side by 12, but whatever I do to one side, I've got to do the other. And I'm going to be left with 12 times by a quarter, well, or a quarter of 12. So that's 12 divided by 4, which is 3. So 3 equals x. To find out the other one, I can use that same formula. 0.25 equals the image size, which is 5, over the object size, which is y. For this one, I'll have to take a couple of extra steps. I'll have to multiply both sides by y to work out what to do next. And that's going to leave me with 0.25y equals 5. And then if I divide both sides by 0.25, now you might be able to have seen this from the start and do a quick switch around. But if you can't see that, that's fine. So 5 divided by 0.25. Oh, I pressed the wrong thing. Very old calculator here at home. I don't have my trusty work calculator. So that's going to give me a distance of 20. So make sure you get these notes in your booklet from here on OneNote. Then I want you to do those exercises there in the appendix exercise. You should now also have your exams back. Have a look through those. I'll post some full solutions sometime this week. I'm hoping to do that sometime tomorrow. We'll see how we go. And then tomorrow you will start the next unit, which is on mass and energy measurement of those things. So hook in and I'll see you on Wednesday.